this meeting. Professor Chomsky has lost his voice. Almost, not completely. He's not completely voiceless, but he will help himself with this microphone. Sessions will run, as you know, from 10:30 to about 12:30 in the morning, from 4 to 6 in the afternoon. It includes his talk and discussion. Professor Chomsky, we are gathered here many different people, linguists, philosophers, psychologists, and scientists from many kinds. Not just from Catalonia universities, but from all over Spain. As I told you when you arrived yesterday night, it's a pleasure and a great, great honor for us that you came to this year. Thank you very much.
Thank you. Tablet, if you want some tablet,
Well, I'm kind of hoping that as the adrenaline starts to flow, the voice will pick up. Can you hear me in the back? Yeah. Okay. If it gets better, I'll put this aside and just talk, but we'll see what happens. And I presume that by tomorrow or so it'll be improved. Incidentally, in general, if you would like to raise questions or objections or bring up points or whatever, please feel free to do so, even more than usual, because it gives me a chance to rest my voice while I listen to you. So at any point in the course of discussion, if you can't hear or you don't understand, or you think it's completely wrong, or you have some other idea, don't hesitate to interrupt. And if I feel that it's taking us too far off the track that I'd like to get to, I'll ask to put it aside and come back, or otherwise we can simply go on. I'm going to follow pretty much the course that was suggested for Luigi, start at a fairly general level and proceed towards more specific questions and issues as time and as shared interest permits and suggests. Starting, I want to talk about what is called the cognitive revolution that began in the 1950s. When I suggested the topic, I also suggested that quotes be put around the word cognitive revolution, suggesting a certain skepticism about its revolutionary character. The skepticism has two aspects to it. One, I'm not convinced that it was as much of a change as many other people think. In my opinion, in many ways, it picked up and recovered ideas, even technical ideas, that are much older, that we can trace to what might be called more properly the first cognitive revolution of the 17th century. And it didn't always improve on those. In fact, in some cases, I think there's been regression. So it's not, in my opinion, as revolutionary as it has been held to be. The earlier tradition had been entirely forgotten by the 1950s. Even in scholarship, it was not known and not understood. That is, scholars knew the books, but they didn't understand what was in them. And in my opinion, that's still more or less the case. I don't think that the riches of the first cognitive revolution have yet been appreciated or understood, except in certain corners of scholarship. The second aspect of skepticism is that my own feeling is that the cognitive revolution has taken, from the very beginning, a rather dubious path, maybe a wrong turn, and that the directions in which it's proceeding should be seriously reassessed from their very origins. And here I would go back further, in this case of the study of language and mind, back, say, to Frege, where I think already there are some intellectual moves made in the study of language and mind that are quite dubious and that have had questionable effects, in my view, negative effects on contemporary theory of reference and many other topics. Now, when I speak of the cognitive revolution, I don't mean to be referring to specific work in, say, the neurophysiology of vision or the study of reasoning under complex conditions and so on. A lot of that work is very respectable scientific work. I'm thinking of the more reflective and considered aspects of the cognitive revolution, those that fall roughly within philosophy of mind, or the parts of so-called artificial intelligence that are concerned with the general nature of the issues rather than constructing an expert system that will solve some technical engineering problem and so on. So I'm really thinking about, when I refer to the cognitive revolution with skepticism, it's at the general level. It's where it intersects with, and in fact falls under, one might say, contemporary philosophy of mind and philosophy of language. Well, that's the skepticism. I'll come back to trying to fill in the blanks. Are you still hearing me? Yes. Okay. If not, wave your arms or something. The study of language and mind, as everyone knows, goes back several millennia, back to classical antiquity. It's often been assumed that these two inquiries, the inquiries into language and into mind, are intimately related, that language is a mirror of mind, as Leibniz put it. If that is the case, then the study of language should provide unique insight into human thought, and that's often been thought to be the case over the last several thousand years. So there have been repeated convergences between the more technical study of language and the more general study of mental events, actions, and processes, and so on. Now, this convergence has taken place in these two cognitive revolutions. It took place about 40 years ago at the origins of what is today commonly called the cognitive revolution. And contemporary linguistics, the linguistics as most of us know it and practice it, developed as part of that cognitive revolution, and in fact has been a significant factor, maybe a major factor, in the development of cognitive science since the modern origins. And this same convergence, in fact, took place during what I call the first cognitive revolution of the 17th century, which was in fact part of the general scientific revolution of the period, the Galilean revolution. The convergence took place in ways which are rather strikingly similar to the convergence of the 1950s in a number of respects. One respect was the stimulus to the scientific imagination that was by automata. Now, in the 20th century, of course, it's been computers. In the 17th and 18th century, it was the remarkable automata that were constructed by skilled craftsmen, starting with extremely complicated clocks and reaching up to the creations of people like Jacques de Vaucanson, a duck digesting food and that sort of thing. And these in both cases, both in the 17th and 18th century and currently in contemporary discussion, the apparent achievements of artifacts raised an obvious question, namely whether humans are not simply more complex machines, more complex artifacts. That was a topic of very lively debate then, as it is today. Now, the Cartesians, notoriously, offered a negative answer to this position. They said, no, humans are not more complex artifacts, although Descartes tried to show that a very substantial part of what humans do, including all the way up to perception and sensation, is just a complex watch or a complex machine. And the same is true, he argued, of all of the entire inorganic world and the entire organic world up to the level of, metaphorically speaking, we might say humans below the neck. I mean that as a metaphor, of course. But he also argued that certain aspects of human intelligence lie beyond the scope of any conceivable artifact. And he appealed specifically to language in this connection. That's where the convergence took place. Crucially, if you look at, say, Discourse on Method and other Cartesian discussions, he appealed to normal aspects of language use as evidence of the kind of phenomena that in principle could not be incorporated within an automaton, even of the most complex and highly articulated kind. Specifically, he referred to a collection of properties that normal linguistic behavior manifests. We can call them, though he didn't call them this, we can call them the creative aspect of language use. Let me call them that. This is a collection of properties which includes the fact that normal language use, I don't mean poetic discourse, just ordinary interaction among people, is unbounded. People are always saying new things and hearing new things that have never been said before in the history of human species. And this goes on constantly and unrecognizably. You have no way of knowing, in fact, whether they're new or not, because they all sound familiar, even if you've never heard anything like them before. So normal speech is unbounded. On the other hand, it's obviously not random. It's not just some device producing things with a random element in it. It's coherent. It's appropriate to situations. On the other hand, it doesn't seem to be caused by situations. In fact, it appears to be completely uncaused. That's not to say that there aren't influences, but it seems to be a paradigm example of the general matter of freedom of the will. If you had a complete description of your internal state and of the surroundings that you're in, still, the Cartesians argued, and phenomenally they seem to be correct, still you could choose to say something other than what is suggested, maybe even strongly pressured by the internal state and the external environment. Like I could right now start talking about the weather in Boston, let's say, or any other topic, and I'm not going to do it because it would be inappropriate. But I could perfectly well do it, and it would be completely coherent, and I could find topics that none of you would be able to even understand, what's happening in my family or something like that. And all of that's always possible, and we know that it's possible. Even given my internal state completely described and my surroundings completely described, I can start doing anything. This, of course, is a much more general problem. As the Cartesians emphasized, in their formulation, a machine is compelled to act in a certain way, up to randomness. Up to randomness, a machine is compelled to act in a certain way by the arrangement of its parts and the stimulus situation. A human being, in contrast, is only incited or inclined to act in a certain way and may choose not to. It may choose in a way to act in a way contrary to its inclinations. So you can choose to act, say, suicidally, and people sometimes do, or in all sorts of other ways. That kind of phenomenon, which is manifested most clearly in the normal use of language, Descartes argued, lies beyond the bounds of any possible automaton. So the fact that language is unbounded, stimulus-free, not determined by internal state, even though heavily influenced by it, appropriate situations, but not caused by situations, in fact, apparently uncaused, not random, evoking thoughts in others that they might have expressed the same way as they understand once they hear the expression. That collection of properties, call it the creative aspect of language use, is, Descartes argued, kind of a litmus test, just as a litmus test is a test for acidity. These properties are a test for some other aspect of the world for some property of the world that does not fall within mechanism. Now, those arguments are not inconsiderable, and I don't think they change at all as we move from the complex artifacts that excited the imagination of the Cartesians to the contemporary artifacts that we use, contemporary computers. Although they're radically different in all sorts of respects, exactly the same reasoning applies. The difference between appropriateness to situations and caused by situations, appropriate use versus random, arbitrary intrusion into deterministic systems, that seems to remain. The automata that we have are either deterministic or have elements of randomness. They could be then probabilistic in their behavior, but none of that matches in the least the properties of ordinary human behavior, so it appears. Now, we could be completely wrong about this. Maybe we're being misled about the facts, but these facts, as the Cartesians argued, seem as obvious to us as anything could be on immediate inspection. And as Descartes again argued, it would be absurd to deny that which appears obvious to us, since we, simply on the grounds that we may not have intelligence enough, or at least we do not now have intelligence enough to understand it. That would simply be irrational. And he therefore argued, and I think we're still in this situation, that we have to take these things very seriously. Well, that was the Cartesian response to the first question, the question whether people are simply more complex automata. Their argument was, yeah, everything is just a complex automaton, except certain aspects of human behavior, language being a paradigm case. Those issues again arose in the second cognitive revolution and the contemporary debate about the Turing test and the kinds of things, say, that Roger Penrose, for example, looks at in his recent book, if you've seen that, and so on. The vast debate about the Chinese room, Searle's Chinese room in the philosophy of mind and artificial intelligence literature. All of this is a contemporary version of it. In my view, a case of regression, however. I think it's extremely misguided, seriously misguided, whereas as the question arose in the 17th century, it was a very sensible question. Maybe the answers didn't make any sense, but the question was sensible and the framework was sensible. I'll try to suggest later that the contemporary framework makes no sense whatsoever and is completely off track. And in fact, in my opinion, Turing, in his original paper in 1950, already pointed out why it was off track. That is, it's been following a line that he suggested people not follow, but I'll come back to that. If you don't know what I'm talking about, I'll come back and fill in these details later. Well, a second similarity between the first and the second cognitive revolution is that in both cases there was great interest in computational theories of the mind. In fact, the great scientific achievement of Descartes, his major contribution to modern science, was the development of a computational theory of vision. He overthrew the prevailing neoscholastic theories of vision, which had a very mystical character to them, kind of common sense in a way, but mystical. At the time, it was assumed that, say, if you see a cube, if I see a cube rotating in space, there's a cube rotating in space in my brain. Okay, so somehow the form of the thing out there, by some mysterious process, gets into my brain and it's in there. And that's what vision is. It's picking up the form of the object and duplicating it somehow. But Descartes ridiculed this idea properly and offered, not only tried to show why it was absurd, but offered an alternative theory. The alternative theory that he presented was a real scientific breakthrough. You can't use it in his form, but it led to modern neurophysiology, modern biology, the modern biology of cognitive processes. He asked, in order to undermine this view, he suggested that we consider the case of a blind man with a stick who's tapping on some object in front of him with a stick, say a chair, and he's getting a sequence of stimuli in his hand. And from this sequence of stimuli, he sort of figures out that it's a chair that he's perceiving. Well, obviously, the image of the chair isn't getting into his brain. The only thing that's getting into his brain are some pressures against his fingers. So there's a sequence of pressures on the fingers from which his mind is somehow constructing the image of a chair. Well, Descartes argued that that's exactly what normal vision is. In fact, given Cartesian physics, he had to assume that there's a solid connection between the retina and an object that you see. There's like a rod, a rigid rod that extends from your eye to the thing you see. And as you move your eye around, it's exactly like tapping on a chair with a stick. It just happens to be that you're getting stimuli on your retina instead of in your hand, but the picture's the same. And he therefore argued that normal vision is just the computational interpretation by the mind, by the brain. In fact, this is automata for him, so by the brain, of a sequence of pressures on the retina, which is exactly like what the blind man is doing. Well, that leads to a kind of a computational theory of vision. It's the inner resources of the mind that determine what you see. So he argued he didn't do the experiment, but we could do the experiment now, and his guess was right. He argued that if you take an infant who's never seen a geometrical figure, let's say, and you present the infant with a triangle, like I draw a triangle on the board, what the child will see is a distorted Euclidean triangle, because of course what you've drawn is not a real triangle. I mean, two of the lines don't quite come together, and one of them's got a curve, and so on. The child, in other words, will not perceive a perfect example of what it is, which is some completely crazy figure, but it will see it as a distorted triangle, even though it's never had any experiences. And the reason Descartes argued is a thought experiment, of course, but it's correct. The reason he argued is that the mind operates by the principles of Euclidean geometry, and when a sequence of stimuli hit the retina, the child's mind creates the Euclidean, the abstract figure, and that's what's seen. And then you sort of notice that what's out there is kind of a distorted version of it. And he argued this is true generally of perception. That whole picture seems essentially correct, and it's been picked up. It in fact was a scientific breakthrough and led the way to a serious inquiry into the biology of vision and perception generally. In fact, that I suppose is Descartes', well, at least one of his leading scientific contributions. It opens up modern physiology. Now, similar ideas have reemerged in the 20th century cognitive revolution and have led to quite productive work in some of the same areas that were, in fact, strikingly the very same areas that were explored in the 17th century, primarily vision and a few other sensory modalities, and language, and a little bit in other areas, conceptual development, reasoning, and so on. In the area of language, the Cartesian revolution did lead at once to efforts to apply this kind of computational point of view. It wasn't regarded then as computational. We would regard it as computational. This computational point of view, which views a mechanical device from a certain abstract perspective. That's about what it amounts, where it's doing, it's carrying out. We view it as having the property of a computational device. That's a collection of states and properties that a device could have. So this account that I gave of the infant seeing the triangle could be redescribed as a kind of a software matter, if you like. That conception reemerged, somewhat reformulated in the 20th century. In the Cartesian period, it set off quite important studies of language, in fact, revolutionary studies, developing what was then called rational and philosophical grammar, which just means rational and philosophical just means scientific in our term. So that would be scientific linguistics. It led to a conception of universal grammar, meaning properties of language that are common to language generally, not to specific languages. And of course, that would be a core part of any scientific approach to the study of language or anything else. It also led to the first real studies of the vernacular. That was kind of unusual at the time. You weren't supposed to study Latin or something like that. But there were direct, for the first time, serious investigations of actual languages that people speak, the vernacular languages, or French, for example. The very fact that Descartes wrote in French was considered remarkable and a real breakthrough. And this has all sorts of political aspects to it as well. All of these were important achievements, later forgotten, but reconstructed in many ways in the 20th century cognitive revolution. Well, the second cognitive revolution has indeed led to real advances in certain areas, strikingly the old areas, vision, language, a couple of others, I mentioned a few. It's not so clear, to me at least, that it has led to any real progress at what you might consider a second level, the level of reflection about the nature of the disciplines that are concerned with what was traditionally called mental acts and faculties. And that's the question that I want to come back to as I proceed. Some of these questions are substantive, some historical. Let me just start with a couple of words about the second cognitive revolution, the one in the 1950s, the one that contemporary linguistics was part of and came out of, and then go back to a kind of a general look at the whole topic. None of these things have a starting date, of course, but George Miller, who was one of the leading figures in the current birth, or I would say rebirth, of cognitive psychology, he, in a retrospective talk on this recently, traced the cognitive revolution, as it's often called, to a meeting that took place in Cambridge, Massachusetts. I've forgotten whether it was at Harvard or MIT, in 1956. It was a meeting of the Institute of Radio Engineers, the IRE. And in fact, most of this work developed within an electrical engineering framework in the 1950s. At that meeting, there were there was a kind of an unexpected convergence of different things, which in retrospect you could say, he argued, set off the cognitive revolution, or at least sort of gave it some kind of form. There were papers on human information processing, human psychology, using new ideas like signal detection theory and information theoretic ideas and so on. There was a collection of papers on those topics. There was the first paper on generative grammar that had been given publicly, a paper of mine, which sort of outlined some of the basic ideas that later became generative grammar. There was also an important paper on problem solving and reasoning. That was by Newell and Simon. I don't recall anymore which one of them gave the paper, but Alan Newell and Herb Simon gave their first exposition of their paper on a program for proving theorems in elementary logic, which was one of the things that set off contemporary artificial intelligence. I should say that Newell and Simon didn't follow the path that became conventional, but this kind of set things off and was considered a major, if not breakthrough, at least stimulus to contemporary artificial intelligence, which hadn't really been formulated yet at that time. Well, that was a collection of papers. They came from different sources. They proceeded in different ways. There had not really been much communication among the people who'd given them. Actually, they were even given in different sessions. But they had some shared ideas, and that was sort of obvious at once. One shared idea was a certain kind of shift in perspective that was common to all of them. A shift in perspective from what we might call an externalist point of view to an internalist point of view. That is, the psychology of the time, study of humans of the time, was externalist in that it was concerned with what's outside the person. It was concerned with behavior, that is, what, some action that's going on, or maybe the products of behavior. So linguistics was the study of products of behavior, was the study of texts, sounds, words, arrangements of words, structures of sounds. And that was true of both European structuralism and American structuralism, different in many respects, but both of them externalist in this respect. Behavior is psychology, paradigm example. You're only interested in what's outside the mind. In fact, it's a kind of a point of principle that you're not supposed to look at anything else. The shift that took place was from this externalist point of view to an internalist one, in which what you're interested in is precisely what's going on inside the mind-brain. Inside the mind, where we think of the mind now as just some set of properties and states and processes of the brain, ultimately to be related to the brain sciences in some fashion. So use the term mind, but without any metaphysical implications. The topic of inquiry shifts totally. Instead of the topic of inquiry being behavior and the products of behavior, the topic of inquiry is what's going on inside the mind. Behavior and products of behavior are just data, and not particularly privileged data. I mean, if they happen to be useful, okay. Data in itself is of no, you never know whether it's any good or not. Data becomes significant when it becomes evidence. Evidence is a relational concept. Evidence for, So data moves into the sciences when it becomes evidence for something, and the something is something about the nature of the world. In this case, the nature of the mind. In my opinion, this shift is a shift from sort of natural history or rock collecting or something like that to the beginnings of what might turn out to be science. It's kind of a shift from natural history to natural science, where data and the products of behavior and behavior and the products of behavior are simply data, useful if they're useful, otherwise throw them out. Most data are useless. And not particularly privileged. If you could find evidence from, say, electrical stimulation of the brain that would tell you something about language, that's just as good, maybe better, than evidence about, the way people interpret sentences or what they do with words or whatever. Data is just data; it's of no interest in itself. Well, it's intellectually speaking, that was an enormous shift, and it was very controversial. And indeed, it remains very controversial today. In fact, if you take such criteria as, let's say, government funding, for whatever that's worth, overwhelmingly government funding, at least in the United States, goes to the externalist work, the statistical analysis of texts, organization of data, that kind of thing. Very little of it goes to the internalist work, which is, in my view, the only kind that even merits being talked about seriously, other than maybe for some engineering application, which rather low-level engineering application that might be useful. Anyhow, that's a personal view. But it was clearly a shift of perspective, and it was taking place at one or another level in all of this work. And I don't want to exaggerate, because among many of the people in the cognitive sciences, they regard this shift of perspective as dubious or wrong. But at least there were hints of it in all of this work, and you can see, maybe better in retrospect, that a move was taking place in that direction. Again, in my opinion, that's a move from natural history, rather boring natural history, to a potential natural science. Maybe it's not there yet, but you can at least see how it might emerge. A second set of shared ideas in this range of papers at this IRE convention was in what you might call computational representational theories. That is, looking at mental activities and mental faculties, what the brain is doing, in other words, looking at it as a kind of software problem. Now, to look at it as a software problem is to take a certain abstract perspective toward the functioning of the machine. You know, it's a perspective that sometimes makes sense, sometimes doesn't make sense. Whenever you're studying some physical object, sometimes a particular abstract perspective makes sense, gives you insight. Sometimes it doesn't. That's what science is about. And in this case, there was a kind of an intuitive shared feeling with anybody saying it, that viewing the brain as abstractly, of course it's purely abstract, as having hardware properties and software properties would be useful. Now remember, this is totally abstract. I mean, even if you look at, even in the case of a computer, we distinguish hardware and software, but you know, you can't pull out a particular piece of the computer and say, I'm hardware. I mean, everything is just hardware. You know, to say that a computer is implementing some software is to view it from a certain abstract perspective, which may make sense or may not make sense. And in the case of the brain, the questions may make sense or may not make sense, much as looking at the planets in terms of kind of rational mechanics, in which, you know, you have mass points observing Newton's laws or something may make sense or may not make sense. It's a matter of to be discovered, not to be stipulated. Now, this point of view was kind of liberating, as it had been in the 17th century. Now, in the 17th century, they didn't talk about hardware and software. But again, in retrospect, I think it makes a lot of sense to reinterpret Descartes' overthrow of the neo-scholastic theory of vision in terms of the picture that I just presented as, in effect, adopting a computational representational point of view and separating the software aspects, the computational aspects, which give you these idealized figures and so on, from the hardware properties, like the sequence of stimuli on the finger or the brain and so on. And in fact, in contemporary work, it's often looked like that. So if you read, say, you know, work in the David Marr School, for example, the distinction is made quite explicit and correctly. I mean, it's led to a lot of progress, which is the only mark of correctness. Now, this is a double-edged sword, in my opinion. I think the move to the position where you look at that mental problem activities as software problems was liberating, and you know, it was a move that should have been made. On the other hand, it can also be extremely misleading, and in my opinion, it has long become more misleading than helpful, particularly in philosophy of mind. In fact, here again, I think that the current, especially those areas of philosophy of mind that are kind of around artificial intelligence, including inquiry into Turing tests and so on, have been seriously misled by the metaphors. I'll come back to that. So, you know, analogies and metaphors and abstractions are okay, but you don't want to make sure that you don't get carried away by them into directions where you shouldn't follow them, and that's never easy to know, of course. Well, that's the general background that I have in mind. I'll try to fill it in as we proceed. Let me now approach the question from an even more general point of view, if you like. Are you still hearing me back there? Yeah. Okay. Well, I'm still being able to articulate, so I'll continue. Let me now try to approach this from another perspective, you know, kind of orthogonal, and ask how one might proceed to study human beings altogether. Well, there's one obvious idea. An obvious idea is that you should study human beings as if they're part of the natural world. That would seem kind of obvious, surely controversial traditionally, contrary to religious teachings and all sorts of other things. But in the, say, post-Galilean period, it should be possible to entertain the idea that you should study human beings as part of the natural world. Now, that doesn't mean that when you study human beings, you're going to find what you find when you study rocks, obviously. But that's normal. It just means that the method of approach should be as if they're part of the natural world. meaning what you should do is search for intelligible explanatory theories that give you some insight into what these objects are about and what they're up to and how they're constituted. And you should you should hope, as in the other areas of natural sciences, you should hope that ultimately this inquiry will be integrated with other aspects of the natural sciences. Typically, over the centuries, parts of the natural sciences proceed in isolation. You don't know how to integrate them with one another. And when you can integrate them, it's a big discovery. So when, say, biology was sort of more or less incorporated in biochemistry about 40 years ago, that's a real breakthrough. When it became possible for physics to understand for the first time such things as why a solid object can exist, which was sort of incomprehensible to the physics of the 19th century, when it became possible to understand, to kind of incorporate within physics elementary properties of the world, like states of matter, or the properties of solids, or the color of sodium, or the character of the periodic table. In other words, the quantum theoretic revolution. That's a real revolution. Nevertheless, quite often in normal science, things just can't be integrated because you don't know how to integrate them. So they proceed separately with an eye to eventual integration. That's normal science. I mean, you get these miraculous moments when things get integrated, but it's not the norm by any means. This approach that says let's study humans the way we study anything else, let's call it naturalistic. By calling it naturalistic, I mean to try to focus attention on the character of work and reasonable goals, and to abstract away from the question of success. So maybe it's completely unsuccessful. That's another issue. So I don't want to use the honorific term science for it, but just like science, in the way it works. By calling the work naturalistic, that's what I mean. I want to abstract away from questions of actual success. Well, that's a kind of a common sense idea. A naturalistic approach would claim that it has no burden of proof to meet at all. It doesn't. It's self-justifying. It need give no justification. Maybe there's some reason not to adopt a naturalistic point of view to humans, but that's what needs justification. You'd have to give an argument for that. So the burden of proof is on anyone who questions this idea. So a naturalistic picture would assume. And I think that that's correct. I mean, unless there's some reason to the contrary, I've never heard one. It seems to me we should agree that unless some argument is given, which hasn't yet been given, there's no reason not to study humans the way we would study rocks or bees or anything else, expecting to discover totally different things, of course, as when we study solids and liquids, we discover totally different things. Well, there are questions, interesting questions, as to how naturalistic inquiry ought to proceed. So what are the criteria of rationality for science? And what about the reality of theoretical entities? And does it make sense to claim that a vector field, which is a mathematical object, has mass, and so on and so forth? There are such questions, all kind of interesting questions. But now, if one is interested in getting answers to those questions, not just harassing emerging disciplines, then the place to ask questions is where there might be a chance of getting an answer. And that's the way you proceed if you're rational. You have some question you'd like to answer. You look at the area where you might find an answer. Now, in this case, that means physics, not psychology. You're not going to find any answers to these questions in psychology. You might find some answers in physics for just the obvious reason. The depth of understanding and the degree of success is so qualitatively greater, by orders of magnitude, that there really are guides to inquiry into these questions. Whereas in the emerging disciplines, half the time you don't know what you're doing at all. So there's just going to be nothing around that's going to guide inquiry. I mean, if you would ask these questions in physics in the Galilean period, you would have gotten all the wrong answers. We know that. In fact, Galileo had a very hard time convincing anyone and had a rather sad fate. precisely because not enough was understood about these questions, so that what he was trying to do was intelligible. I mean, you can only get some insight where there's been some advances. So therefore, the attempt to raise these questions about fields like psychology and linguistics seems to me just a form of harassment. It's of no intellectual interest. Now, you can understand why philosophers do it. Quantum physics is hard. You want to raise questions about quantum physics, you got to study hard, you got to learn things, and you got to think about things, and so on. You want to raise questions about psychology, you can do it off the top of your head, because nothing much is known, so it makes life easier. But that's not a good reason to harass psychology, I don't think. So insofar as these general questions arise, I think we can dismiss them. General questions about, unless some special reason is shown to show that psychology and linguistics, have some special methodological problem that, say, physics doesn't have. Unless that's an argument like that can be given, general questions about, say, induction or indeterminacy or all of these things, we can forget about. They all arise in physics, and if anything arises in physics, we can forget about it. If you want to get an answer to the question, look over there where they really understand something, and there might be some hope of moving forward. There's some insight. There's no point raising these questions here where so little is understood. So I'll put those aside unless there's an argument. Incidentally, this throws out, by this decision, I've thrown out an awful lot of contemporary philosophy, maybe unfairly, but I think fairly. A lot of it, in my view, is just harassment of emerging discipline. So let's put that aside. And the criterion I want to use is this, to restate it. If some general methodological consideration can be shown to hold of language and psychology, but not of chemistry and geology, then we'll consider it. But if it holds of chemistry and geology, we'll forget about it. Okay, that's the working criterion that I'd like to suggest, and I think it's a rational one, based on the assumption that if we ask questions, we do it because we want answers, not because we're trying to harass somebody. If we want answers, we'll look at the place where we might find answers. That's the logic of the criterion I'm suggesting. Well, a naturalistic approach to humans, then, will put aside any general methodological issues that just arise in the course of rational inquiry generally, and will simply take for granted what is done in normal science with all of its uncertainties and equivocations and problems. Always with an open mind, of course, like, maybe somebody will come up with a real methodological question. And then it will proceed to study humans in the way that you study anything else. You try to find an intelligible explanatory theory that gives you some insight and opens up new paths of investigation and leads to new kinds of empirical question you hadn't thought about before, and so on, that sort of thing. Well, that's the naturalistic approach. An alternative approach which rejects naturalism, we might call, although I'll qualify this, let's call it dualistic. A dualistic approach says that humans just aren't part of the natural world, and you have to study them in some quite different way. Now, here we have to be a little more careful, because a naturalistic approach could lead to a certain kind of dualism. So, for example, Cartesian metaphysical dualism, in my view, was completely naturalistic. That is, it was the outcome of a way of looking at human beings naturalistically, and it led to a conception that humans have some special property, just like acids have some special property that bases don't have. There's nothing dualistic about chemistry because it says acids are different from bases, and you can tell the difference by a litmus test. And there's nothing non-naturalistic about Cartesian metaphysical dualism if it says that there's some special property that humans above the neck have, and there's a litmus test for it, namely things like the creative aspect of language use. I mean, that can be wrong, but it's not non-naturalistic. So dualism, I don't mean dualism and naturalism to be exclusive categories. There's a form of dualism, namely metaphysical dualism, the traditional form, which could follow from a naturalistic approach and could even be right. In fact, let's have a look at how it, so the kind of, what I mean by sort of pernicious dualism, irrational dualism, is a kind of epistemological dualism, not metaphysical. One that says we're not allowed to study human beings the way we study other things. There's a law which I state which says you're not allowed to approach humans by the same procedures of rational inquiry that you apply elsewhere. That may seem to be a crazy point of view, and I mean to suggest that it is indeed a crazy point of view, but I'll also suggest that it's the overwhelmingly dominant one in philosophy of mind and cognitive science. In fact, maybe almost universal. So I want to take a strong position on that controversial position. So therefore, I'm putting it in the craziest possible form. And then what I'll try to argue is that what actually is done, in fact, falls under this rubric. That's the path I want to follow, just to look ahead. Well, all right, let's go back to traditional dualism and say take the Cartesian form, traditional Cartesian metaphysical dualism, and remember the way it worked. In outline, Descartes argued sort of as follows. He had a conception of the physical world. He gave a conception of physics. The conception of physics is what was called in those days the mechanical philosophy. Philosophy is just a word for science. So philosophy means science. So the mechanical philosophy meant mechanics. And mechanics was kind of a common sense mechanics. It was a sort of contact mechanics. Things can influence one another if they're in contact. That's the crucial idea. Like I can't move the moon by moving my arm, let's say, because they're not in contact. That's just common sense. Happens to be wrong, but it's common sense. Okay, so that's common sense contact mechanics. And Descartes gave a kind of, sketchy account. I mean, it's not a detailed account, but a sort of sketchy account of how you might cover all of the phenomena he claimed of the inorganic world, the organic world, most of things about humans, everything except these few things that I mentioned, in terms of the mechanical philosophy, in terms of a kind of contact mechanics. Well, all of that's, and then he said, look, here's these phenomena that are around, like the creative aspect of language use, which don't fall under this. Therefore, we need a new principle, completely rational. We need a new principle because they're not covered by the mechanical philosophy. Within his framework, the only way to set up a new principle was to introduce a new substance, but that's part of the framework with which he approached it. So you introduce a res cogitans, another principle, thinking substance, which has other properties. And then from a naturalistic point of view, you have two questions. First of all, what's its character? What is it? What is the res cogitans? Nobody actually knows whether Descartes had an answer to this. If you look at his major book, the Traité du Monde, this big study of the world, there's only 3 volumes. There was a 4th volume, which was supposedly devoted to the mind, and legend has it that he destroyed that volume after he heard what happened to Galileo. Whether that's true or not, I don't know. Maybe all the secrets are in there, like Fermat's last theorem or something. But in any event, there's nothing much around from the theory of mind. But that would have been the problem. One problem would have been, okay, if you've got this separate substance, tell us what it is. The second problem would be the standard unification problem that arises in the sciences altogether. That is, show how this theory relates to other theories. Now, in the terminology of that day, it meant solve the interaction problem, show how mind and body interact. That's the way in which the standard unification problem of normal science is stated in terms of a two-substance theory of the structure of science. And remember, a two-substance theory of science is perfectly rational. I mean, it may be completely wrong again, but most theories have always been wrong. There's nothing irrational about it. We can, I think, without doing serious violence to, in fact, maybe even providing some understanding to the history, rethink it in this form. So we have a naturalistic approach which claims to show that a whole range of phenomena of the world fall under contact mechanics, so identifies some phenomena that don't fall into it, invokes a new principle, then should proceed to study that new principle, developing a theory of mind, which would be like a theory of chemistry or genes or something, and then solve the unification problem, show how it falls in with other parts of the theory of the world. And it looks as if that's what Descartes was trying to do. in Principles of Philosophy and Traité du Monde and all that sort of stuff. Inside, these are the parts of Descartes that nobody ever reads. The parts of Descartes that people read are things like Discourse on Method, which was like a research grant proposal. I mean, it wasn't serious. He was saying, look, support me, I want to work on this topic. Or the Meditations, where he's trying to answer questions that philosophers raised about all this. But from Descartes' point of view, as much as you can reconstruct, it seems that what was important was the science, dioptrics, things like that. And the other stuff was thinking about the nature of the science. Well, since the science is mostly, in fact, almost all, maybe all, outmoded, you don't study it. But for that matter, nobody much studies Galileo either, because it's done differently and better. But that doesn't mean that it wasn't important to him, What remains is the talk about the science. And since there's been no progress in that at all, you can make perfectly good sense to read, say, Discourse on Method. But I think one should read it recognizing that for Descartes, this is peripheral. It's not central. If you want to understand the project, you have to look at it his way. When you reconstruct it his way, I think you find a very naturalistic project, which ends up with metaphysical dualism as a serious proposal about the nature of the world, which could very well turn out to be right, like other serious proposals about the nature of the world. Well, so again, this is dualism, but it's not non-naturalistic. It's naturalistic dualism. Maybe wrong, but naturalistic within the spirit of science. Well, all of this has been ridiculed, especially in the modern period, as the idea that there's, as Gilbert Ryle put it, a ghost in the machine, and then you're supposed to laugh. There's a ghost in the machine. Isn't that silly? But that mistakes the problem completely. It's true that Cartesian metaphysical dualism didn't outlast the century, but it was not because of problems with the ghost. The theory of mind, such as it was untouched. What Newton exorcised was the machine, not the ghost. In fact, what Newton showed is, contrary to everyone's expectations, including his, you had a ghost all the way down. That is, even ordinary matter and the most elementary dynamics had ghostly properties. It wasn't just the mind. Everything is ghostly. So Newton showed that contact mechanics amazingly just didn't work. It was true that you could influence things at a distance. Now Newton, scientists of the day, including Newton incidentally, thought that this was absurd. Newton himself called universal gravitation an occult property. And he said anyone with any brains at all can see that it's inconceivable that something can influence something that it's not in direct contact with. Yet we seem to have to assume that. Well, now, from his point of view, I mean, some major scientists of the day, people like, say, Huygens and others, just threw it out for this reason because it was idiotic. Newton was himself torn by it, He realized that it's just got to be right because it was such a spectacular breakthrough. On the other hand, it made absolutely no sense because it was inconsistent with mechanical philosophy. And what, in fact, happened is he didn't get rid of the ghost in the machine, but he just showed that all properties of matter are ghostly. It's all a ghost. It's all unintelligible, all the way down to terrestrial motion and planetary motion, which is a big problem and remains a big problem. And it led to a totally new way of looking at science. This has been pointed out repeatedly. Bernard Cohen, who's maybe the major Newton scholar, points out, I'll just quote his version of it. He said by entering into this paradoxical world, he said Newton set forth a new view of science in which the goal is to find the best theoretical explanation, irrespective of any intuitive notion we may have of ultimate explanation. The point is there is a ghost in the machine, and that's just the way the machines are. They're ghostly. Can't do anything about it. The mechanical philosophy appears to be wrong. Although it's self-evidently true, it just seems to be wrong. From this point on, we must find his quote. we must be satisfied with universal gravitation. Let's call it UG for short. I'll come back to that. We must be satisfied with UG and that it exists even if we cannot explain it in terms of the self-evident mechanical philosophy. That's just where we are. Science means accepting UG if you have evidence for it, and it provides you with an intelligible scientific theory, even if there's no way of accounting for it in terms of what's self-evident, namely the mechanical philosophy, which you just have to admit is wrong, even though it's self-evidently true. From this point on, people's intuitions about what must be true become irrelevant. They just become irrelevant. So if the way to deal with universal gravitation is through curved space-time, okay. If the way to deal with the universe is through weird quantum mechanical effects, too bad for intuition. If the world really is made up of infinite one-dimensional strings in 10-dimensional space, okay, stuck with that. Time has a beginning, fine, time has a beginning. Whatever lunatic idea people will come up with tomorrow has to be evaluated in its own merits. Does it yield insight and understanding? Does it help us come to terms with the nature of the world? If it does, it satisfies the conditions for rational inquiry, irrespective of our intuitions. The Newtonian revolution, in fact, even earlier, the Galilean revolution, I think that's its essential content. It's kind of general content. It's sort of that. From then on, you're off on a totally new path. That's why it's really the one real scientific revolution in human history. It just set inquiry off on an entirely new path, and that's where we are. We have no other criteria. Common sense criteria are irrelevant. Now, we can't get out of our skins. I mean, you go out in the evening and you see the sun set, and no matter what you know, you still see the sun set. And when you see the moon near the horizon, it's just bigger than when you see it up there. You can't not see the moon illusion. So we see the world in terms of the way we are. Can't help it. Just like we intuitively feel that the mechanical philosophy must be true, because how could it not be? But we have come to recognize that the way we see the world is just another fact to be explained about the world. So if we see the sun set and we see the moon illusion and we believe in the mechanical philosophy, no matter how much we try not to, that's just a fact about the world. In fact, it's a fact about a very special part of the world, namely the human mind brain and the way in which it acts and conceptualizes and constructs and so on, and we'd like to come to understand that. And in order to do it, we have to make a kind of an intellectual wrench. We have to take ourselves out of our skins and look back at ourselves kind of reflexively as part of the world. And that's hard, but, that's what it means to to study human beings naturalistically. So that's the move one has to make, to study human beings naturalistically. And then the way we look at things in common sense no longer provides a criterion for intelligible explanation, but rather is just a phenomenon to be explained. Now, there's a real problem here, which you can see right off. Whatever the working notion of intelligible explanation is again something that's inside our skins, and we're stuck with that. That's something like a real paradox. We can only, whatever our capacities to carry out rational inquiry may be, say some corner of our brain, which let's just call it the science-forming faculty to dignify ignorance with a title, but there's some part of our brain that enables us to carry out rational inquiry, and it uses its own resources and its own criteria, which may be as misleading as the moon illusion. Maybe it's always systematically leading us away from the nature of the world. If we're creatures of the world, that would not be in the least surprising. But there we can't do anything about it, because we're stuck with those. That's as deep as you can go. You can't go beyond those. So if we're systematically misled about the world because of the way our science-forming faculty happens to be constructed, that we can't do much about. But we can overcome the moon illusion. It's hard, but we can overcome it. We can't stop seeing it. Can't stop seeing the sun setting. You can't stop believing in the mechanical philosophy. Newton's intuitions are, at least my intuitions, but that part you can throw out. The part that's guiding our search for intelligible theory we can't throw out. There's no way to get out of that. And there you are approaching something which is kind of like classical paradox, maybe. But we have to recognize from the naturalistic point of view that we are just a particular organism trying to understand the world, and we've got to do it our way because there is no other possibility. Well, so anyway, getting past through metaphysical dualism, we've now abandoned metaphysical dualism, but abandoned it in a very special way. It's not that there's a ghost in the machine, it's that the machine has ghostly properties all the way. You know, maybe it has even more ghostly properties above the neck. If so, okay, but that's just another fact. However, it's already unintelligible to common sense down to elementary dynamics. That's Newton's basic discovery. That's why contemporary discussion ridiculing the ghost in the machine is completely off track, in my opinion. It's just missing the point of what happened. There was no criticism made of the Cartesian theory of mind. You could argue that's because it wasn't substantive enough, maybe. But in any event, it survived all of this intact, such as it was. What did not survive is the theory of the machine. Contact mechanics was thrown out. And the common sense of the next scientific generation is that the mechanical philosophy is wrong. Actually, it took a long time for this to settle in. You know, for a couple of hundred years in physics, people were trying to find mechanical explanations. And it really wasn't until probably the 20th century that that was given up. You get as late as people like Poincaré. He was arguing that the molecular theory of gases we adopt only because, as a computing mechanism. And the only reason we adopt it is because we're familiar with the game of billiards. So it's kind of convenient computing mechanism. And efforts to try to explain things in terms of, you know, ether and stuff like that are an attempt to carry out mechanical philosophy. And it was a long time before. It was really this century before Newton's insight was basically incorporated into the sciences. And it's harder maybe even to do it in the emerging sciences. But anyhow, I think in retrospect, that's the way we have to look at it. Well, if this is correct, then so I'm being kind of anachronistic when I say that the 17th century exorcised mechanical philosophy. It did in principle, it didn't yet do it in fact. It left a big residue of unhappiness and confusion that took centuries to sort out. But looking back, it seems fair to say, you know, abstractly speaking, that Newton exorcised the machine. He got rid of the mechanical philosophy. Footnote, it's an anachronism to say it that way, but I think an accurate historical reconstruction. And I'll continue with historical reconstruction. Well, one consequence of eliminating the machine is that we've gotten rid of any notion of body or physical or material. There no longer is any notion of the material world. Remember, Descartes could be a dualist because he had a notion of body. Body, not a very clear notion, but at least a general notion. Body is defined by the mechanical philosophy, by contact mechanics. That's body. Okay. Now, Newton showed that's not the way body works. So therefore, we have no conception of body. In fact, there's just a world, whatever it is. You know, if the world has mental properties, that's part of the world. But there is no notion of body. Unless somebody comes up with a new notion, and nobody's ever done that, unless somebody comes up with a new notion of the physical, talk about physicalism or materialism or eliminative materialism or the mind-body problem and so on, just seems to be meaningless. Now, if this is correct, something very curious has happened because people are talking about it all the time. There's all kind of stuff right up to the present about the mind-body problem. And there are theories in the cognitive sciences, say the Churchlands, called eliminative materialism, which says we shouldn't study the mind, we should just study the material world. And there's a lot of questions about physicalist reductionism. Can we reduce things to physical terms? In fact, you know, this is universal in philosophy in these areas. But I don't know, I don't understand it. Maybe nobody can explain it to me. It seems that once we have lost the notion of physical, none of this discussion is even meaningful. It doesn't mean anything. You can't have a problem of reducing things to the material if there's no notion of material. And there is no notion of material. What is it? I mean, somebody could say, well, it's what they teach over in the physics department. But the people in the physics department will tell you that's not true, because they expect 2 years from now to be teaching something else, at least if the subject's still alive. So that can't be true. And there is no other notion. All we have is the world with whatever properties it has. There's no notion of material world or physical world. Hence, all of the problems of reduction have disappeared. The problems of elimination of study of the mind in favor of neurophysiology or something don't mean anything. They're just purely irrational statements saying instead of studying this part of the world, let's study that part of the world, if you want to. But that doesn't make any more sense than saying since solids are hard to study, let's study liquids. Maybe, okay, but it's of no more interest than that. Unless somebody can come along with a theory, with a concept of the material to replace the Cartesian concept, which has been thrown out the window. And as far as I know, nobody has even addressed that problem, let alone offered an answer to it. And if so, again, let me try to put it in the strongest terms, virtually all the discussion in the field is not just wrong, but meaningless, literally without meaning. It's talking about a problem that's unstatable. That's the strongest version of the position I'm trying to take. So let me put it in the most outrageous form possible. The whole field is not wrong, but meaningless, talking about something that it can't characterize, namely something that presupposes a notion of physical, which has been abandoned since the 17th century. That's the strongest version of this particular thesis. Well, with metaphysical dualism now unstatable, because we don't have any body anymore, notions like eliminative materialism and so on lose sense, and the kind of natural conclusion to draw from Newton's demolition of the theory of matter, and that's what it was, is to, the natural conclusion is to say that human thought and action, say creative aspect of language use, are just properties of organized matter, because that's all there is, There's nothing else, so they're just properties of organized matter. And in fact, that conclusion was drawn sporadically, but not too long after. It was drawn first by La Mettrie, then it was about a century later, half century later, and it was considered totally outrageous. In fact, his work hasn't been revived until this century. La Mettrie was driven out, he was a doctor, and he said, his argument was, look, thought must be just a property of organized matter, because there isn't anything else. He was driven out of France, driven out of Holland. He finally survived thanks to the protection of Frederick the Great for some reason. About a generation later, in more tolerant England, the same idea was developed by the eminent chemist Joseph Priestley, a major 18th century scientist, who argued that, let's see if I can find his quotes, he argued, I'm quoting him now, that thought in humans is a property of the brain. It's the necessary result of a certain organization. It's like electricity and magnetism and the powers of attraction and repulsion. That's what he compared it to. Nobody really understood those things. But whatever electricity, magnetism, and the powers of attraction and repulsion are, these ghostly properties that matter has, thought is just another one of them. It's another one of those ghostly properties, and we have to investigate it in these terms. Another 18th century version is that the brain secretes thought, the way the liver secretes bile. That's kind of the image. Actually, if you look at people like John Searle today, he seems to be saying something more or less similar to that, if I understand him correctly. Well, that looks like the right move, mainly because there's no other choice. There doesn't seem to be any other move you could make. I mean, since all there is a world which has ghostly properties all the way down to elementary dynamics, there's nothing to say except that properties of attraction, repulsion, and electricity and magnetism and later on quantum effects and thought and whatever else is around, anything that's going on, is just some property of the world, some property of the way matter is organized, where matter now has no meaning. It's just whatever there is. Some property of how whatever there is organized has these features. And a naturalistic approach to humans ought to proceed that way. Well, that leads us to the next question. How can organized matter have these properties? Well, on that question, progress has been essentially zero. We don't know we have nothing to say about how organized matter can have such properties as the creative aspect of language use. In that respect, we're exactly as much in the dark as the Cartesians were. It's not that matter and mind are different kinds of things. That can't be, because there doesn't seem to be any such kind of thing as matter. So therefore, matter and mind can't be different kinds of things, there being no matter. So they're not different kinds of things, but if we think of those terms as descriptive conveniences, describing certain aspects of the world, namely humans above the neck versus everything else, then it seems that matter and mind pose different kinds of problems to human intelligence. That appears to be the case. Maybe they'll be shown to be wrong. Like there was a time when electricity and magnetism, and for that matter, universal gravitation, also posed total mysteries. And maybe we just haven't learned enough. But for now, it seems reasonable to suppose that matter and mind, though not different kind of things, do pose different kind of problems to human intelligence. Well, if that turns out to be true, it would not be in the least surprising to a naturalist. Remember, a naturalist perspective assumes that humans are just part of the world, not angels. They're just another thing in the world. If they're a thing in the world, they're going to have certain cognitive capacities, like rats. A rat can do certain things and it can't do other things. It's very lucky for a rat that it can't do lots of things, because if it wasn't incapable of doing lots and lots of things, it wouldn't be capable of doing anything. There's a logical relation between scope and limits. If you have the capacity, if you don't lack the capacity to do many things, you can't have the capacity to do anything. Very simple reason. The capacity to do something requires articulated structure. And if you have articulated structure, it's going to rule out all sorts of other things. The point is obvious in the case of physical growth. An embryo has particular genetic instructions, very rich genetic instructions, which are going to allow it to become a chicken. But that very structure is going to prevent it from becoming a monkey. Okay? So lucky for a chicken that it lacks the capacity to become a monkey, because if it didn't lack that capacity, it couldn't become a chicken. And the same thing, assuming that the world doesn't change somehow when you move to cognitive function, the same thing's going to be true about cognitive function. So rats happen to be very good at solving what are called radial mazes. A thing like this, where you stick the rat in the middle, and it's got food out here. These are kind of like spokes of a wheel, and the trick is to learn how to go down each path exactly once. Like, remember, you didn't move down that path before. And in order to make it as hard as possible, the experimenter will rotate the thing so the rat can't be using olfactory cues, remembering he smelled his way down there or something. Rats turn out to solve that very fast, probably faster than humans. So they're really good at radial mazes, but they're horrible at other mazes. So, for example, I don't know if you take, say, a right, left maze, turn right, turn left, turn left. Rats can't. I think they can't do it at all. But if they can, it's certainly extremely hard. Humans can do it quite easily. If you were to, say, set up a prime number maze where a rat has to turn right every prime number of branch points, obviously the rat would never do it in a million years. And the reason is it just doesn't have that concept. It doesn't have that concept in its head. A rat can do a lot of things we can't do. Like it can build a nest and find its way home and solve radial mazes and all sorts of things, because it has special capacities. but it can't do things like a right, left maze, which humans can do. And as I say, it's kind of lucky for a rat that it can't do all these things, because that means it has the structure to do other things. Well, if humans are part of just to introduce some terminology, we might distinguish for a rat between what we could call problems and let's call it mysteries. And by problems for a rat, I mean areas of challenges, say intellectual challenges, that can in principle be resolved within the rat's cognitive space. It's got the concepts for it. It may take a long time, but it's got the concepts for it. By mysteries, I mean things that are just outside its cognitive space altogether, like a prime number maze, or probably a right, left maze. Okay. The analogy in say embryology would be that becoming a chicken is a problem for a chicken embryo. Becoming a monkey is a mystery. It just hasn't got the capacity to do it. You can't change the nutritional environment of the cell in order to make a chicken a monkey, Actually, nobody knows that. It's just taken for granted. I mean, rational people looking at the world just assume that. They have no real knowledge of it, to explain it. It's just sort of so obvious that nobody even talks about it. I'll come back to that fact, because it's interesting that in the study of cognitive development, people aren't rational that way, the way they are in embryology. That's part of the epistemological dualism I'll come back to. Anyhow, in the areas where we can all be rational without too much trouble, like chicken embryos and rats, the distinction between problems and mysteries is quite clear. Notice it doesn't have to be a sharp distinction. It could be graded, and there could be all sorts of other dimensions and so on. But as a first approximation, it makes sense to distinguish these two categories. And it may even be very sharp. Well, if humans are part of the natural world, the same is going to be true of humans. That is, there'll be problems, there'll be mysteries. There'll be intellectual challenges that are within our cognitive reach, at least in principle. And there'll be others that are just not within our cognitive reach, in principle. And if that is true, if there are certain things we can't understand, we should be very happy about it, because that's a consequence of the fact that we can't understand anything at all, okay, for just reasons of logic, same as a chicken embryo. Well, in theory, we could find out something about this. I mean, looking at ourselves from abstracting from our skins and looking back at ourselves, we could carry out an investigation that might set the boundaries of those things. For example, we might discover that there are certain kinds of intellectual constructions that humans are capable of setting up. Like humans, if you look at science, let's say, there are certain ideas that keep cropping up. Like we can study input-output systems. We can study deterministic systems. We can study probabilistic systems. We can study systems with a random element. There's a number of things we can do. And if something can be put into those frameworks, we can deal with them. On the other hand, it may very well be that the creative aspect of language use just doesn't have those properties. It's an aspect of the world that just lacks those properties, exactly as the Cartesians thought, in which case it would just be a mystery for us. Free will, in other words. The same might be true of the problem of consciousness. In fact, all the old chestnuts, all the questions everybody's been worrying about for thousands of years, where you never make any progress at all. I mean, literally zero. People don't even have bad ideas about it. Like on some areas, you have bad ideas. But in these topics, you don't even have bad ideas. It just looks like you're bumping into a blank wall. I mean, you know as well as you know anything that you're aware of some things, not of others. You know as well as you know anything that you have a range of freedom of choice of action. You can choose other than what is impelled by you. You know that the Cartesians were right in saying that whereas a machine is compelled, a human is only incited and inclined and could decide to resist those inclinations. You just know that as much as you know anything. And it just looks like a total mystery. There isn't any idea, however bad, as to how that might happen. I mean, there are ideas about, quantum mechanics and so on, but they don't even reach the level of bad ideas because they always introduce random elements. And we know that this is not random. It's no more random than it's determined. It's somehow appropriate, but not random. In fact, it's just uncaused. Not uncaused in the sense of random, but uncaused in the sense of undetermined but appropriate. And what that means, nobody has any idea. We can recognize it. We have no problem recognizing it. We can pick it out all the time, you know. In fact, pretty easily. We have the foggiest idea what it is. Well, it could be that we're facing something like a right, left maze for a rat. In other words, it could turn out to be true that the domain of the mental for humans is just a mystery, and hence not metaphysically different, because there are no metaphysical differences, but epistemologically different, part of our mystery space, not our problem space. There's actually a book coming out by an Oxford philosopher now at Rutgers named Colin McGinn, who arguing that it's in press, that philosophy is just the study of mysteries in this sense. That's why philosophy is hard, because it's the study of mysteries. You can never make any progress. Actually, there's a traditional view of philosophy which would make this almost tautological. One traditional view of philosophy is that it was what's called the mother of the sciences, meaning things are philosophy as long as you don't understand them. As soon as you begin to understand them, they become science. Then philosophers don't worry about them anymore. So in the contemporary period, say, people like John Austin, Oxford philosopher, strongly advocated that. And the person who developed the theory of speech acts. And he argued that he was a Oxford philosopher, but he said what he was working in was pre-science, the theory of speech acts. And whenever it came to be understood enough, it would go off and become part of the sciences, and then they wouldn't talk about it in Oxford common rooms anymore. They'd really work on it, you know. Well, if that's what philosophy is, if it's the mother of the sciences, then by definition it's the study of mysteries, you know. So its problems really are kind of hard in some special sense. Now, notice that what's a mystery for a rat may not be a mystery for us, and conversely. So the notion of problem and mystery is organism dependent. It's just a fact about particular organisms, okay? So it's really problem and mystery sub, we're some organism. There's no absolute sense in which something's a mystery, presumably. Like, it could be a Martian for whom what's a mystery to us is trivial. Maybe he's watching us all the time and wondering why we always make the same dumb mistake when we study mental phenomena, just as we can watch a rat and wonder why it always makes the same dumb mistake when it's running a right, left maze. And things that are mysteries to the Martian might be trivial to us. There's no commensurability necessary in this space. But nevertheless, it's something like that. Something like that has to be true from a naturalistic point of view. That is, again, if humans aren't angels, if they're part of the natural world, then this is going to be true. Now, we don't know what the boundary is, but we know it's there. And in fact, coming back to the question of the natural sciences, it would seem that the natural sciences are a sort of an accidental convergence, purely chance convergence between some properties of the world and properties of our cognitive space. So somehow, by some pure accident, it turned out that if this is the properties of the world, and this is a set of things that are just problems for humans, there's some area of convergence in there. There's no reason why that had to be like that, you know. And there's a long discussion in the sciences, or philosophy of science, trying to argue that it had to be like that. I think this goes back first to Charles Sanders Peirce, about a century ago, in the early post-Darwinian period. Peirce argued that he asked, scientists have always been asking the question, how come science is so successful? It's kind of a miracle, you know. Like Einstein, not foolish scientists, Einstein asked the question, how come, you know, the human mind is capable of understanding the nature of reality? Well, of course, that presupposes that humans are capable of understanding the nature of reality. And the evidence for that is very slight. I mean, in fact, what seems to be the case is that through the general obscurity, there's a few little points of light that have broken through, and that's what we call science. But most of the questions that the Greeks asked, let's say, are just as obscure today as they were then. I mean, a few of them, a very small number of them have been answered. So first of all, the fact to be explained doesn't seem to be a fact. The fact that humans have this amazing capacity to understand the nature of the world just doesn't seem to be true. Most of what's going on, we haven't a glimmer of understanding about. So since the fact isn't a fact, we really don't care what the explanations for it are. But the explanations that have been offered, from Charles Sanders Peirce up to people like Stephen Hawking in his recent popular book on time, are always the same mistaken explanation. Namely that the reason for this fact, which is not a fact, is evolution. Evolution selected us to be able to solve problems. Therefore, we're able to solve problems. But that doesn't make any sense at all. I mean, there was nothing in the history of the human species that gave a reproductive advantage to ability to solve problems in number theory, let's say, or in quantum theory. In fact, human evolution took place in hunter-gatherer societies. Nothing's happened since then. And there's no reproductive advantage, even in modern societies, but certainly in hunter-gatherer societies. There's no reproductive advantage to the capacity to solve problems in the advanced sciences, in sort of triviality. And that's all evolution's about. It's just about reproductive advantage, not of anything else. In fact, it's even been, serious evolutionary biologists have been trying to ridicule these notions for years, have even argued only half jokingly that there's a selective advantage for stupidity. Dick Lewontin, who's one of the best population geneticist at Harvard, one of the main modern evolutionary biologists, trying to debunk all kinds of stories about cognitive development and so on, suggested that if you really look back at hunter-gatherer societies, where all of human evolution took place, and if you consider the people who, for some genetic reason, were more adventurous or more imaginative or whatever, chances are they'll get killed, although they'll be good for the tribe. That is, while all the dumb, unimaginative guys are sitting around the fire, this imaginative guy is going to be out trying to figure out a way to catch the saber-toothed tiger. Well, maybe he'll succeed now and then, in which case it's good for everybody sitting around the fire. But over time, it tends to be bad for him because he often fails, and the saber-toothed tiger gets him. So there's a reproductive advantage to being passive, stupid, unimaginative, and so on. And therefore, he argues, well, there ought to be a tendency in that direction. As I say, this is only half serious, not entirely unserious, incidentally, but merely an effort to debunk the idea that you can learn anything about the evolution of cognition. Dick Lewontin's major point is that nothing within any scope that we can dream of, there's nothing possible that anybody will ever be able to say about the evolution of the language faculty or the evolution of cognition, and certainly not the evolution of the science-forming faculty. It's just hopeless. It's got to be just some physical configuration that took place for whatever reason. And I think that's correct. That doesn't mean that there isn't a lot of work on it, but the work looks vacuous for those kinds of reasons. In any event, it looks as if it's reasonable to suggest that science, as we know it, is just a kind of ray of light which accidentally happened to break through because of some chance convergence between our problem space, which is part of our nature, and the world, which is whatever it is. And already by the 17th century, big paradoxes were arising because our problem space is sort of wedded to the mechanical philosophy, and we had to give it up and move to some other parts of our mind which have whatever properties they have, which may be systematically misleading us and may be leading us away from inquiry into the mental. Now, in the post-Newtonian era, suppose this is true, suppose that certain aspects of the mental, like, say, creative aspect of language use, the litmus test for the mental, for the Cartesians, so not something trivial. Suppose that really turns out to be, in fact, a mystery for humans. Well, we're just stuck with it. You know, that's the way we are. We're stuck with it the way we're stuck with the moon illusion. And maybe it's a problem not only for our perceptual space, but even for a mystery, but even for our cognitive space, in which case we'll never have any understanding of it, just as we have no understanding of most problems. That doesn't mean we can't deal with these things in our normal lives. Like in our normal lives, we're always dealing with things, more or less successfully, that we haven't any conception of. You know, we do it by what's called intuition, which is just a name for what we can do, but without any understanding of how we're doing it. And virtually everything that goes on is by intuition. Fortunately, we've got all these capacities, whatever they may be, but to gain a scientific understanding of them is something else. That we will ever be able to do so is, I think, kind of unlikely. And in fact, you might even argue it's a good thing. You know, it's nice that we don't understand ourselves too well. Could be awful if we did understand ourselves too well. But anyhow, it just looks plausible to assume that most of our humans above the neck will just never understand. We can begin to pick particular, we'll be able to do it. We can do all kinds of things, but we probably won't be able to understand it, at least so it looks. And certain aspects of the mental appear to look like that. They just appear to be in the mystery space. Again, that could be wrong, but let me stress again that this could be a research topic. You could imagine, investigate, in fact, it could come out of cognitive science. It could come out of cognitive science that humans are capable of constructing certain kinds of conceptual structures, like determinism and randomness, say, and those are going to deal with certain types of phenomena. And if you can show empirically that certain arrays of phenomena don't have those properties, too bad. Then you're in the mystery space. That's a conceivable discovery about human beings, conceivable empirical discovery. Without paradox, we could discover what's a mystery for us. Couldn't solve it, but we could find it, find out where it is. And a large part of the so-called mind-body problem could ultimately fall into that area. Again, not metaphysical, because we can't state it. Well, with metaphysical dualism unstatable, is there another kind of dualism? Remember, metaphysical dualism falls within naturalism. It's just a form that naturalistic inquiry takes. It reaches metaphysical dualism along the lines, say, that the Cartesians followed, and then it's exploded because the world disappears. The machine disappears. So we're left without any form of metaphysical dualism. We have no matter anymore. Is there any other kind of dualism that we could construct? Well, the only other kind is irrational dualism, epistemological dualism, which says you're just not allowed to study humans or humans above the neck by the methods of rational inquiry. You're not allowed to study humans naturalistically. Now, as distinct from metaphysical dualism, this is a completely irrational position, as far as I can see. It has no saving graces at all. What I want to show, I guess I'll stop now and come back to that, is that however irrational it may be, it's pervasive. In fact, it dominates, and in fact, maybe even almost universally dominates the more reflective, more considered aspects of the cognitive sciences. By that I mean contemporary philosophy of mind, contemporary philosophy of language, artificial intelligence, debates about the limits of machines, can software think, all that kind of stuff. What I want to try to argue is that all of this is ultimately, if you look at it closely, at each point, it's a departure from a naturalistic approach to humans, meaning it's a form of epistemological dualism, hence irrational dualism, unless you can give an argument for it. There might be an argument for treating humans non-naturalistically, but the burden of proof is on anyone who suggests that. And you await an argument, in other words. If you don't get one, you forget about it. That's what I'd like to argue, and to the extent that that's plausible, the last question, which I'll come back to at the end, is why. I have to show that it's plausible. But assuming that it's plausible, why would it be true? Well, there would be a natural explanation, namely that intuitively we are just dualists. We can't help being dualists any more than we can help seeing the sunset. We see the sunset no matter how much we know, and probably our approach to the world, humans, is just, ineradicably dualist. We see humans as having ghostly minds in a physical body, and even if the notion physical body disappears, we can't help seeing people that way. Just as once contact mechanics has disappeared, and once the Ptolemaic universe has disappeared, we can't help seeing the sunset. Now, with metaphysical dualism, if this is true as an aspect of human cognitive character, if metaphysical dualism is on a par with the setting of the sun, just a way we can't help looking at things, with metaphysical dualism gone, we're forced to irrational dualism. But it's a path we should resist. That's the diagnosis I'd like to give at the end, but first we have to traverse the path. So let me stop there. Very polite.
Any questions? Yeah, any questions? There's a microphone here.
At the beginning of the lecture, you were careful in distinguishing between two levels of cognitive science. The kind of first level of cognitive science, which is an empirical inquiry, experimental inquiry into certain cognitive capacities that is characterized by certain properties, externally, computational, representational approach, and so on and so forth. And the second level, which is what's called more reflective or second order cognitive science. And then we think so. In the end, it's an important point because the users of cognitive science that with no further qualification was perhaps worthwhile to stress now that the criticism that you express only refer to one aspect, not to the other.
That's correct.
I think it's fair to say that looking at the first level of science, some genuine problems.
Oh, yeah. Yeah. No, I completely agree with that, and I think it's worth stressing. So in the actual inquiries, say into vision or sensory perception or language, I mean, the stuff we work on, there have been real breakthroughs. I mean, I think really revolutionary breakthroughs. They're considered it's this second level cognitive science, the kind we could call philosophy of mind. In fact, they're pretty much the same field. That's the one I'm talking about. And strikingly, actual working cognitive scientists tend to be sort of schizophrenic about this issue. I mean, some of them don't think about the general topics at all. But those who do think about the general topic, which is normal, and reasonable. I'm not suggesting everybody think about reflectively about what they're doing. Like, not many chemists think about what chemistry is about. They just do it. But in those among the cognitive scientists who think about the topic, they generally, in my opinion, move to the irrational side when they're thinking about it. So somebody may do work in which they, use computational representational models of, say, vision, and then they may argue that this doesn't make any sense. Incidentally, that's not something unknown in the history of the more advanced sciences. Maybe some of you can, I'm sure some of you know way more about this than I do, so add things that I'll know. But, as you may know, one of my colleagues at MIT up until recently was Tom Kuhn, down the hall, who's a well-known historian of science. And I have been we've been friends for years, and I've been interested in exploring with him similar things in the natural sciences. And interestingly, it hasn't been studied much. he couldn't refer me to any literature on it. So, like, you know, if you ask the question, how did this transition go from, say, Poincaré regarding the molecular theory of gases as just a computational device to people assuming there really are molecules? You know, there's a whole bunch of things like that. He couldn't refer me to any literature, actually only to one study, an unpublished study, or how it, in Newton's period, which has been heavily studied, how did people get from regarding universal gravitation as an occult property, which no sane person could even dream of, which was Newton's point of view, to recognizing it as just obvious, you know, by the time you get to, you know, Laplace or somebody. How did that transition take place? There doesn't seem to be much work on that. And I think that's right at the heart, exactly where we're in, you know. The one study that Kuhn referred me to is a book, actually a dissertation by a guy named John Heilbrunn, who was actually a student of his, who did a doctoral dissertation on the things like the molecular theory of gases, on the transition around the turn of the century from a period in which molecules and atoms and so on were regarded as just computing devices. You know, like Poincaré said, we use them because we're familiar with billiards. We just want to get the answers. Up to the point where people really just assume they're there. You know, there really are molecules. And according to this guy, if you go back to, say, 1880, scientists were completely schizophrenic, just like cognitive scientists are today. I mean, when they were doing their work, you know, they treated molecules as being as concrete as Bunsen burners, you know, no distinction. On the other hand, when they were thinking about it, they said it's total nonsense. Doesn't make any sense. There can't be such things. Field, you know, molecule, any of this kind of business. These are just ways of coming up with the right answer, you know, kind of very operationalist. And then he says that you go about, there's about a 20-year period from about 1890 to 1910 when attitudes just shift totally. And by, say, 1910, people just talk about them as being like Bunsen burners. I mean, later, you know, comes quantum theory and new problems arise. But in that period, you know, like this period, people just thought of them very, you know, substantively. And his argument, his reconstruction is that what happened basically is that, for example, lots of different ways of calculating the number of molecules in a certain volume of gas, lots of different ways of doing that converged, giving you very close to the same number. And there were all kinds of convergence of this kind. And the convergences were just so powerful, along with the elegance of the theories that were coming out, that at some point it just became unreasonable to question it, no matter how much of a wrench it was with common sense. Well, in my opinion, it'd be nice to understand this better in the natural sciences, because it might give some hints, you know, as to where we're being caught in traps and things, if you look at what happened in places where they've already been through this a long time ago. My impression is that in the cognitive sciences today, there's something similar going on. So that in the actual work, the sort of first-level cognitive science, people are doing perfectly sensible work and making advances and so on and so forth. When people are thinking about that work, including often the very same people who are doing it, it sort of flies off into outer space. Based on illusions. And it's that second level of cognitive science, the philosophy of mind part, that I really am talking about now. Yeah.
I have two questions to ask. The first one is in the consideration of the computational properties of the mind, just in the period of Descartes. Besides the automatus, maybe it was an influence of considering mathematics as a computational mean, as a language. Do you think that it has an importance, the consideration of mathematics as a computational language, also in that time?
At that time? Well, of course, Descartes is famous for analytic geometry, basically, giving a numerical interpretation of geometry. I don't know if at that time there was anything like a real conception of mathematics as a formal system in our sense.
No.
That didn't really come till Hilbert, way later. I mean, right through the 19th century, classical analysis was just some kind of hand-waving. So, Gauss couldn't have explained intelligibly what he was doing. It didn't really get what we call formalized until mid-19th century. And so I don't know, but my impression is that those ideas were not influential in the first cognitive revolution. I mean, what formalized mathematics meant at that time was Euclid, which was pretty close to formalized, though, as Hilbert pointed out, when he redid it properly, there were lots of gaps, But, that was the model of formalization, and that model didn't really give you a notion of formal language or anything like that. In the mid-20th century, it's been very influential and extremely harmful in my point of view, I believe. Now, actually, it's double-edged. Like the concept of the concepts of formalization that led to the notion of recursive procedure, like, say, Turing machine and so on, that was very productive. I mean, it made it possible to face classical problems in a clear way for the first time. On the other hand, the idea of formal language, I think that's been extremely misleading. Virtually all of Quine's work, for example, on natural language, seems to me to be derived, I'll come back to this, from a model of formal arithmetic, which just has no resemblance whatsoever to natural language. Doesn't have any of the same properties. And the conclusions that are drawn from the study of formal arithmetic are totally irrelevant. I mean, formal arithmetic begins by stipulating a class of well-formed formulas. I'll come back to this in more detail, but just think of, say, I mean, I'll talk about Quine particularly because it's absolutely, beyond any measure, the most influential modern philosopher in this area. Tremendous impact. And if you look back at the thinking about natural language and about psychology, it comes from a model which starts like this. It says, let's take formal arithmetic. Okay, how does it work? We stipulate a class of symbols. We construct certain mathematical objects, which are strings of these things. We then select a certain infinite set of those mathematical objects. We call them the well-formed formulas. We then pick any recursive procedure we like to generate that set. We call it an axiom system. The axiom system is completely free. We can pick any one we like. We do it for convenience or something. The only thing that has any reality is the class of well-formed formulas. And that has reality because we stipulate it. Like we could stipulate the class of even numbers or something and then pick any method of generating them we like. The method of generating them is irrelevant. You just use whatever one you feel like. The thing that's real is the set, extensionally. Now, he approaches natural language the same way. He says what's uncontroversial is the class of well-formed formulas. What's problematic is what's called the grammar, the generative procedure that characterizes them. In fact, he argues crucially that to say that one grammar rather than another is the true grammar is like saying that one axiom system rather than another is the right axiom system for arithmetic. Well, that would obviously be ridiculous in the case of arithmetic. So therefore, by analogy, it's ridiculous in the case of natural language. And that, as soon as you make that move, you're off into some totally non-naturalistic direction. And the trouble is you can't make the first step. There's nothing in natural language analogous to the class of well-formed formulas. It doesn't exist. The only thing that exists is the generative procedure. The thing that doesn't exist in formal arithmetic does exist in natural language, and conversely. So it seems to me that the analogy has been extremely misleading from the first moment on. Although the concept of generative procedure itself has been has been crucial. Made it possible to study for the first time things that people could only wave their hands at before. This has had for the linguists among you, it's had a terrible effect in linguistics. From about 1970 up till today, as the linguists all know, there's been a huge debate about the generative capacity of different kinds of grammatical theories. You know, like, do they generate all recursively enumerable sets? Or can we cut them down so that they generate only recursive sets? Or can we cut them down so they have only the capacity of context-free grammars, which is supposed to be a big ideal that you're supposed to try to reach? And in fact, a lot of the argument against so-called transformational grammar, since work by Stan Peters, or even earlier, Hilary Putnam, has been that it's too broad and weak generative capacity, generates too many sets, it generates wild sets, you know, and we don't want that. We want it to generate only non-wild sets. And now this, I call this a debate, but it's really one-sided, because only one part of only one position is being represented in the debate, those who think it's a problem. The other side, which is basically me, isn't participating because there's no problem, because there's no question. There's no question. You can't talk about generative capacity unless you have a class of well-formed formulas. And there is no such thing. Nobody's ever told us what it is. You know. Nor is there any gap in linguistic theory that would be filled if you had such a concept. I mean, it's not that there's a kind of a theory out here and, you know, there's some things we'd like to explain, and if we could only figure out this concept, we could explain them. That's not true. I mean, there's nothing around which we would understand any better if somebody specified the class of well-formed formulas, and furthermore, nobody knows how to do it. Furthermore, every working linguist, here, get back to Luigi's point, every working linguist knows, at least on one side of his brain, that it doesn't make any sense, because working linguists are typically working in areas of relative judgment. Like, the most productive work has to do with things like the differences between subjacency deviations and ECP deviations, you know, two kinds of deviation. That's, you know, what's going to be useful evidence. You never know in advance. It's usually something very exotic, not what's in front of you. And that evidence turns out, for all kind of theoretical reasons, to be extremely illuminating. Or it takes the study of parasitic gaps, a certain kind of construction, which are very odd. You know, when you tell them to people, they kind of cringe, although they interpret them in very special ways. Now, you know, the ways they interpret them are extremely illuminating. In fact, precisely because they're very odd. They're very odd because nobody ever hears them. So any way they're interpreting is something that's coming out of their minds, you know. So they happen to be very interesting, but they're all deviant. Well, are they well-formed or aren't they well-formed? Well, it's a stupid question, you know. They have exactly the status they have, you know. The status they have is deviant in this respect. There is no notion of well-formedness. Now, every working linguist knows that in their bones, you know. No one has ever proposed, has given a vague idea what the class of well-formed formulas might be. There's no gap in linguistic theory that is asking to be filled by this concept. In other words, the concept